if one body affected by three forces, and we can represent these three forces in by a sides of triangle in cyclic order, then the forces are in. If three forces acting at one point and they are in equilibrium, then the magnitude, and all of them going out from this point, the magnitude of each force proportional to the sine of the angle between the other two forces. That means F1 over sine theta 1. Theta 1 is the angle between F2 and F3, equal F2 over theta 2. Theta 2 is the angle between F1 and 3, equal F3 over theta 3, which is the angle between F1 and F2. Body of weight 60 Newton. That means we have a body, its weight vertically down 60 Newton, right? Sorry, it's placed on smooth inclined plane, which inclines by 30 degrees to the horizontal. So we have the horizontal line and the plane inclined to the horizontal by angle 30. Now, of course, any vertical line with any horizontal line makes 90 degrees. So the weight makes 90 degrees with the horizontal line. Of course, the third angle in this triangle will be 60, right? Then, what are the forces act on this body now? Till now we have the weight, which is vertically down, and also we have this body act or on the smooth plane at one point. So the smooth plane has a reaction, okay? It's perpendicular. Any smooth plane, the reaction will be perpendicular to it. So from this point, the body act at this point, so the reaction will be at the same point but perpendicular to the plane, make 90 degrees, right, with the plane. Then the body is pulled by a string, okay, and this string is go with the greatest, in the direction of the greatest slope of the plane. That means going up, right? So we have the third force here, or the tension inside the string, or the third force. Find the tension and the string and the reaction of the plane on the body. Now we have three forces and the body, of course, in equilibrium. So I can apply Lemmy Rule. First, find the angles between each force, between the forces. The angle between the force and the reaction, of course, it will be 90. But we have here first weight over the angle between R and F, which is 90. So 60 over sine 90 equal F over sine 150, or tension over sine 150, equal R over sine 120, because the third angle, this is a straight line. If we have one of them 60, the supplement of 60 will be 120. Then cross multiplication, we can find the tension, which is equal 30 Newton, and also the reaction of the plane, which is 33 Newton. Body in equilibrium on a smooth inclined plane under the action of force acting along a line of the greatest slope upward. First, we have the horizontal plane and the inclined plane. Okay. Then the body, I'm going to let the angle between the inclined plane and the horizontal plane equal theta. The body acts at a point on the smooth plane, so the body has a weight which is equal W, and of course the body acts at the smooth plane, so the plane has a reaction, and this reaction will be perpendicular to the plane, right? Look at the triangle here. We have 90 and theta. Of course, if we have one angle equal 90, that means the sum of the other two acute angles will be 90. One of them equals theta, so the other will be 90 minus theta. Then the reaction of the plane, which make a 90 degree with the plane, right? Then the third force will be in the direction of the greatest slope of the plane. That means going up like this, and the magnitude of this force equal half W. Now we have three forces, and all the forces are in equilibrium, we can, the body, sorry, in equilibrium, so we can apply Lemmy's rule, right? Finally, we have a straight line here. If one of the two angles will be supplementary, one of them equal 90 minus theta, so the other angle will be 180 minus 90 minus theta, right? Finally, after simplifying, it will be 90 plus theta. Then we have three forces here. First one equal R, and the second one equal W, and of course the angle between them equal 90 degree. Sorry, it's F equal half W. Finally, we have the weight, which is vertically down, and the angle between W and F equal 90 plus theta, but the angle between R and W equal 90 plus 90 minus theta, which means 180 minus theta. Here we have apply Lemmy's rule. W over sine theta equal F over sine 180 minus theta. F or half W equal R over sine 90 plus theta. Now, as we studied before, sine 180 minus theta equals sine theta, but sine 90 plus theta will be cosine theta. So make a cross multiplication between the first and second ratio. W times sine theta equal half W times sine 90, which is equal 1, right? Now I have W sine theta equal half W. Cancel W with W. Sine theta will be equal 1 over 2. That means theta equal what? 90. So again, I have W over sine 90 equal R over cosine 90. 30. So I can find the R equal root 3 over 2W. Body of weight W is placed on a smooth inclined plane to the horizontal line at angle theta. Now we have a smooth inclined plane, and the body and the angle between them equals theta, and the body acts at a point on the plane, so we have the weight of the body, which is equal W, and of course the reaction make a 90 degree with the horizontal line. Finally, of course the angle will be 90 minus theta, the third one will be 90 minus theta. Then the reaction of the plane, which is perpendicular to the plane, a horizontal force of magnitude 40 Newton. Horizontal makes a 90 degree to any vertical line. That means the angle between F and W equal 90 degree. To keep the body in equilibrium, find W and the reaction. And we have that tan theta equal 5 over 12, right? That means the opposite over adjacent will be 5 over 12. Here we have two parallel lines between a horizontal line and the horizontal force. So I can say that we have two corresponding angles. The measure of the first theta, so the measure of the second will be also theta, right? Now we have three forces. The first one equal R, second one equal F, which is 40 Newton. What about the angle between them? It will be, of course, here we have 90 degree plus theta, it will be 90 plus theta, right? Then we have the third force, which is the weight of the body, make 90 degree with the force F, and finally the third angle will be 90 plus 90 minus theta will be 180 minus theta. Then apply Lemmy's rule. So R over sine 90 equal 40 over sine 180 minus theta equal W over sine 90 plus theta. Finally, I can say that sine 180 minus theta equals sine theta, and sine 90 plus theta, of course, equal cosine theta. So R over sine 90 means R over 1 equal 40 over sine theta. How to find sine theta? Go to the triangle. Here we have 5, the opposite equal 10 theta equal 5 over 12. That means the opposite equal 5 and the hypotenuse equal, sorry, opposite over adjacent, and the adjacent will be 12. Find using Pythagoras the third side, it will be 13, right? Then find sine theta, it will be 5 over 13 equal W over cosine theta will means adjacent over hypotenuse, which is 12 over 13. make a cross multiplication. Finally, R equal 104 Newton and W equal 96 Newton. Body of weight 6.5 Newton suspended by two strings of length 0.5 and 1.2 meters. We have a body, and the body of this weight equals 6.5 vertically down, suspended by two strings. We have two strings. The length of the first equal 0.5 meter, and the length of the second equal 1.2. 0.5 meters means 50 centimeter times 100, and 1.2 times 100, it will be 120 centimeter. The two other ends fixed at 2 points on a horizontal line. That two strings are perpendicular to each other. We have angle 90 between them, and the other ends suspended by a horizontal line. Find the tension in the strings. Type. Finding the length of the third side by using Pythagoras, 50 square plus 120 square, it will be 130. The first force will be the tension, and the angle between T1 and T2 equal 90 degree. Okay, and the line of action equal 120, and the second one equal 150. Finally, the length of the third side, it will be 130, and we have a weight vertically down. Type. We need to find the line of action, the triangular forces in this problem. First, I'm going to extend the line of action of weight. If I extend this line, so this is a vertical line, and we have here a horizontal line makes the angle 90 degree, right? Type. So point D, at point D here we have a right angle. So ABC is the triangle right, and also AD perpendicular. If the angle between the line of action of weight and T1 equal alpha, and the other angle it will be theta, of course, alpha plus theta now equal 90 degree, right? Type. Look at the triangle ADB, right at D. That means the measure of the other two acute angle equal 90. So alpha plus what equal 90? As we said in the first statement, alpha plus theta equal 90. So the measure of the angle B equal theta. And also apply this method in the second triangle ADC. This triangle right at D. Of course, the sum of the other two acute angle will be 90. So theta plus what equal 90, as we said before, plus alpha. So the measure of angle C equal alpha. Finally, we can apply the triangular forces or Lemmy type. Lemmy will be more easier here. We have the first force equal T1, and second one will be T2. The angle between them 90. Then the weight act vertically down. Type. If I said that, look at the triangle here, we have the first angle equal theta, so the supplement of this angle CA W, it will be 180 minus theta, and the other angle would be 180 minus alpha. So I can say that T1 over 180 minus theta equal T2 over 180 minus alpha equal 6.5 over sine 90, right? I said T1 over sine 180 minus theta, it will be sine theta, and T2 over sine 180 minus alpha, sine 180 minus alpha equal sine alpha. Finally, 6.5 over 1 equal T1. How to find sine theta? Sine theta, go to the right angle, the triangle. Sine theta equal opposite over hypotenuse. That means 50 over 130. And also T2 over sine alpha. Sine alpha will be opposite over hypotenuse. It will be 120 over 130. Finally, I can by using cross multiplication I can find the length of, or sorry, the value of T1 equal 2.5 and T2 will be 6 Newton. Of course I can apply also the triangular forces in this case. I can extend the line of action of W and also take a parallel line from to T1 or T2 and make a triangular forces using Pythagoras theorem or Euclid theorem. I can find the length of the sides, but it will be more easier using Lemmy's rule. Body of weight 50 Newton or 50 gram weight is suspended by two strings, the length of one of them 90 and the other 120 centimeter. Here we have the body of weight 15 suspended by two strings, the line of action equal 90 and the other will be 120 centimeter. Finally, it from 2 points on the same horizontal line and 150 centimeter apart. That means the distance between them will be 150 centimeter. Right. Most of the time, if the length of the three sides given in the triangle, that means most of the time that means the triangle is right angled triangle. Try to find the value of 90 square plus 120 square. It will be 150 square, converse of Pythagoras. So I said that most of the time, not all of the time. Okay, find the magnitude of the tension in the string. If I extend the line of action of weight, that make a 90 degree with the horizontal line, of course, because this is a vertical line and this is a horizontal line. Here we have two perpendicular, T1 and T2 are two perpendicular line of action of T1 and T2, of course. So if I can say that the angle between the weight or the line of action of the weight and the line of action of tension T1 equal alpha, then the other angle will be theta. As in the previous example, here we have alpha plus theta equal 90. Look at the small triangle, it will be right, alpha equal the second angle will be theta in the small triangle and the second angle will be alpha in the other small triangle, like this. Okay, type. Finally, I need to find the tension in the string. Of course, here we have three forces, T1 and the angle between T1 and T2 equal 90 and the weight vertically down. If I can say that the line of action of the weight is a straight line, so if one of the two supplementary angle equals theta, the other will be 180 minus theta. If one of two supplementary angle will be alpha, then the other angle will be 180 minus alpha. Apply Lemmy's rule. It will be T1 over sine 120 minus theta equal T2 over sine 180 minus alpha, finally equal 15 over sine 90. Simplify, sine 180 minus theta equals sine theta, sine 180 minus alpha equals sine alpha, then 15 over 1 equal T2 over sine alpha equal T1 over sine theta. How to find sine theta? Look at the right angled triangle here, it's opposite over hypotenuse, means 120 over 150. How to find sine alpha? It's also using the same triangle, it will be 90 over 150. That means finally I can find T1 equal 12 gram weight and T2 equal 9 gram weight. Body of weight 120 suspended by two strings OB and OA, inclines at angle of measure 60 and 30 to the vertical line. Type. First we have a body, and this body has a weight 120 Newton, act vertically down, suspended by two strings. Here we have two strings T1 and T2, one of them inclined to the vertical with angle 60 wall and the other with angle 30. Right. Here we have two parallel lines, the line of action of weight and the two vertical lines are parallel. If one of the here we have two supplementary angles, if one of them equals 60, then the other would be 180 minus 60 equal 120, and also 30, one of the two supplementary angle equals 30, then the other will be 150 degree. How to find the third angle? All of them accumulative at one point. It will be 360 minus 120 plus 150. It will be 90 degree. Apply Lemmy's rule. T1 over sine 150 equal T2 over sine 120 equal finally weight over sine 90. Cross multiplication. Finally, T1 equals 60 Newton and T2 equals 60 root 3 Newton. Light string of length 170 centimeter. Its end A fixed to the ceiling of room and from the other end B a lamp. Here we have first light string of length 170. Its end fixed on the ceiling. Here we have the length of the string equal 170, and at the end of this string there is a lamp of weight 136 Newton or gram weight. Okay, finally this lamp has a weight, and of course the other force will be the tension in the string till now. Type find the magnitude of the force required to keep this lamp at a distance 80 centimeter from the ceiling. That means we have another force act on the lamp and make this lamp at a distance. What does it mean distance? Vertical distance or perpendicular distance equal 80 centimeter. So I have here the lamp, and of course the weight act vertically down and the tension in the string, and we have a force, horizontal force. This horizontal force make the lamp at distance 80 centimeter from the ceiling. That means we have the distance from the lamp to the ceiling equal 80 centimeter, and the length of the string equal 170. We need to find the tension in the string and of course the force. Type. Look at the triangle ABC. Now we have 80 and 170. Try to find the length of AC using Pythagoras. Of course it will be 150 centimeter. Type. Finally, we can find the triangle of force. Here we have the tension represented by the line AB and the line of action of W represented on CB. Finally, I can take a parallel line from the force. It will be AC, right? So I can say that F over 150 centimeter or 150 equal tension over 170 equal W over 80. Cross multiplication, F will be 225 gram weight and tension will be 289 gram weight. Body of weight 60 newtons suspended at the end of string whose other end is fixed at a pin on a vertical wall. First we have a body. The first force, the weight of the body vertically down, equals 60 newton. Then this body is suspended by a string. We have the second force will be the tension in this string, and the other end fixed at a vertical wall. That means here we have a vertical wall, and that means we have two parallel lines, the vertical wall and the line of action of the weight. If the angle between the tension and the wall considered to be theta, then the other angle, this is a U letter, two parallel line, two interior supplementary angles, so this second angle will be 180 minus theta. Then the body is pulled by a horizontal force of magnitude 2√3 Newton. That means that the third force will be horizontal. Make a right angle with the weight, vertical and horizontal. Here the angle will be 90, and the magnitude of this force equal to √3. How to find the third angle? All of them accumulative at one point, so it will be 360 minus 90 minus 180 minus theta. After simplifying, it will be 90 plus theta. Then we are going to apply Lemmy's rule, which is the weight over sine 90 plus theta equal the force equal over 100 sine 180 minus theta equal the tension over sine 90. So we are going to replace or simplify the following terms. So 6 over sine 90 plus theta, it will be 6 over cosine theta equal the force equal to 3 over sine 180 minus theta equal sine theta equal tension over sine 90, which is equal 1. Cross multiplication, that means 6 sine 90 equal to √3 cosine theta. Find sine over cosine, divided both sides by cosine theta. Finally it will be sine over cosine equal to √3 over 6. What about sine over cosine? It means tan theta equal 1 over √3. After simplifying, shift tan or tan minus 1 over √3, it will be 30 degree. After finding the angle theta, finally you can say that 2√3 over sine 30 equal tension over sine 90. Finally the tension will be 4√3 Newton. Metallic sphere. Regular sphere means that the weight acts at the center of the sphere. The weight equal 1.5 kilogram weight and its radius equal 25. Now we have the first force, the weight of the sphere vertically down 1.5, okay, suspended from a point B on its surface by a string of length 25 centimeter. From a point on the surface, okay, we have a string. This string is fixed, its other end A is fixed at a point on vertical wall. Here we have vertical wall, and the sphere touch the wall at a point, of course, and this point, of course, the wall has a reaction which is perpendicular to the wall, like this, okay, and finally the sphere is suspended by a string. Of course, the radius equal 25 centimeter, and here we have the string at the point A equal the length of this string equal 25 centimeter. Of course, also the radius equal 25 centimeters, so the distance from the center to the point of intersection with the wall equal 25 plus 25, which is 50 centimeter. Finally, we have three forces are the reaction of the wall, weight, and tension in the string. Of course, we have lengths in this question, so we are going to apply Lemmy's rule or triangle of forces, right? But here we have BM equal half AM, right? That means the side which is opposite to angle 30 half the length of the hypotenuse. This is a right angled triangle, so angle A equal 30 degree. If we have a triangle 90 degree and 30, so the third angle will be 60, right? Here we have BM is a straight line, so I can find the adjacent supplementary angles, which is 120, right? Finally, we have three forces. First R and A, tension, the reaction, the tension of in the string. Then the weight. What about the angle between the tension and the reaction? Equal 120 degree. Finally, the weight is perpendicular to the to R, or the reaction. And also we have the angle between the tension and the weight equals 60 plus 90, 150. Finally, apply Lemmy's rule. R over sine 150 equal tension equal over sine 90 equal W over sine 120, W equal 1.5, cross multiplication. Finally, find the result. R will be root 3 over 2 and tension equal root 3. Also, we can apply triangle of forces here. R, the line of action of R represented by BM, right? And also I can take the tension on the side MA. Finally, I can move the weight to the perpendicular wall, which is BA. So I have finally ABM as a triangle of forces. We have the three lengths, 25 and 50, and we can find the length of AB, which is 25 root 3, by using Pythagoras theorem. So we can apply the triangle of forces or Lemmy's rule. Smooth sphere of weight 15 Newton on a vertical wall and suspended by a light string from a point on each surface. First, we have a sphere. Of course, the first force is the weight of the sphere vertically down equal 15 Newton. This sphere on a vertical wall, smooth vertical wall, that means the reaction of the wall will be perpendicular to the wall. Touch the wall at the point B. From point B, the reaction will be perpendicular to the wall, right? Here we have the first and second force, then string, and from a point on each surface the suspended by a light string. So from a point on the surface we have a string. The third force will be the tension in the string, right? Type. Attach a point on the wall above the point contact between the wall and the sphere. If the length of the string equal the radius length of the sphere, that means the line of action of the tension equal R. The length of the line of action of tension will be equal the radius, that means equal R. So if the distance from the point fixed on the wall and the center will be R plus R, it will be 2R, right? Also, we have BM equal R, right? Find the pressure on the wall and the tension. Here we have ABM is the triangle of forces. Why? Because BM represents the line of action of A, the first force, which is the reaction of the wall, and the tension, the line of action of the tension, represented by MA. Finally, I can move the weight parallel to it, so it will be represented by AB on the wall, right? So ABM is a triangle of forces. Type. We have here the length of AM equal to R and the length of BM equal R. We can find the third side by using Pythagoras. It will be root 3R. What does it mean? That means square root 2R all power 2 minus R power 2. Finally, it will be 4R square minus R square. 4 minus 1 equals 3R square. Under the square root, it will be root 3R. طيب apply the triangular forces. That means T over 2R or AM equal R or the reaction over BM, which is represented by R, equal AB over root 3R. AB sorry, the weight over root 3R, weight which is equal 15. Cross multiplication, the tension will be finally 10 root 3 Newton, and the R will be 5 root 3. And we also can say that the side which is opposite to angle 30 half the length of the hypotenuse, that make angle A equal 30 degree, because the length of BM equal R and AM equal to R. So the length of BM half the length of AM, that make angle A equal 30, and I can complete the angles and find or apply Lemmy's rule. Okay, and this is another solution. Metallic smooth regular sphere of weight 100 Newton and its radius equal 30 centimeters, suspended from a point B on its surface by a string of length 20 centimeters. Finally, we have sphere. Of course, the weight act at the center, vertically down, equal 100 gram weight. Then suspended from a point on B on its surface by a string of length 20, and the other A fixed on at a point on a vertical wall, smooth vertical wall. If it's on a vertical wall, that means the wall has a reaction which is perpendicular to the wall. This is the second force. Finally, we have the tension on the surface of the sphere, represented, or the line of action of this tension equal 20 centimeter, and also the radius of the sphere equal 30 centimeter. So the distance from M to A, it will be 30 plus 20, finally 50 centimeter, and also BM equal R, that means 30 centimeter. Finally, I can find the length of AB using Pythagoras theorem. It will be 40 centimeter, right? Of course, we can apply the triangle forces. The line of action of tension represented by the side MA, and the line of action of R represented by BM. Finally, I can take a parallel line from the weight. It will be AB, represented AB on the weight. Finally, I can say that 100 or W over 40 equal R over 30 equal tension over 50. Cross multiplication, R will be 70 Newton and or gram weight, and tension will be 125. Sphere rests between two parallel rod lies in the same horizontal plane. That means we have a sphere, and this sphere rests on two rods, and of course at the two rods touch the circle at one point, so the rod has a reaction, and this reaction will be perpendicular to the rod, right? Then the sphere has a weight of 10 Newton at the center. Then we have R1, which is the reaction of the first rod, and R2, which is the reaction of the second rod. Of course, the reaction will not be perpendicular to the sphere, okay? It's not perpendicular to the sphere. And the distance between the two rods equal R. That means in triangle ABC we have the length of AB equal R, of course AC equal R, and also CB equal R. That make the triangle ABC is an equilateral triangle. That means a measure angle A equal B equal C equal 60 degree, right? Then what about the line of action of the weight? The line of action of the weight divide the vertex into or bisect the vertex angle, divide 60 degree into two equal parts, that makes 30 and 30. طيب here we have two vertically opposite angles, that means 60 will be equal to 60. طيب what about the straight line? One of them equals 60, then the other will be 180 minus 60 equal 120, and also the second, the last angle will be 120. Finally we have three forces, the weight and R1, R2. How to find the angle between R1 and the weight? It will be 30 plus 120 means 150 degree. طيب then R2 and the angle between R1 and R2, of course it will be 60 degree. Then find the angle between R2 and W. R2 and W, it will be 120 plus 30, also 150. And finally the angle between R1 and R2, it will be 60. Apply Lemmy's rule. R1 over sine 150 equal R2 over sine 150 equal W over sine 60. That means R1 equal R2 equal 10 root 3 over 3. Sphere of weight 30 Newton rests between a vertical smooth wall and inclined smooth plane, inclines by 60 degree with the horizontal line. Find the pressure on each of the wall and plane. First we have a sphere, and the weight, the first force is the weight of the sphere act at the center point, equals 30 Newton, right? This wall rests between a vertical line, so we have a vertical line, the sphere touch this line at point, so the wall has a reaction at this point perpendicular to the wall, right? Then a smooth inclined plane, that means a plane inclined to the horizontal by angle 60 degree, right? Here we have horizontal and vertical, it will be 90 degree, the angle between them equal 90 degree. So the rest of the angle, or the remainder of the angle, equal 30 degree. Then we have two planes and both of them are smooth plane, so the reaction will be perpendicular at the point to the plane from this point. But we have the first reaction act on the inclined plane, which is R1, and the second one will be make 90 degree with the plane, and the other will be the reaction of the wall equal R2 and also perpendicular to the wall. Here we have two parallel lines, of course, the line of action of R2 and the horizontal line. We can find the angles by many ways, okay? Here we have a triangle here, the line of action of R2 and the inclined plane and the vertical wall make a right angled triangle. We have 90 degree here we have. I'm going to try to again, I'm sorry. Here we have right angle, the triangle, okay? First angle equal 90 and the second 30, the third will be 60 degree, right? Type. So I can find the other angle in the small triangle. Here we have 90 degree, okay? I have here 90 degree. Again, I'm sorry. We have 90 degree, 30 degrees, so the third, 60 degree, the third angle will be 30. Then I have 30, and three forces are in equilibrium of magnitude 7, 8, and 13 Newton. Find the measure between the first and second force. If we have three equal forces and we need to find the angle between 7 and 8. To keep the three forces in equilibrium, the sum or the resultant of any two forces must be equal to the third in magnitude and opposite direction. To keep the three forces in equilibrium, the resultant of any two forces equal the third force in magnitude and opposite in direction. That means the resultant between 8 and 7 should be equal 13 in magnitude and opposite in direction, right? So I have here two forces equal 7 and 8, and the resultant of them equal 13, and we need to find the angle between them. Apply the rule of resultant of two forces, r square equal f1 square plus 2 square plus 2f1 f2 cosine alpha. Try to find alpha. Substitute, that means 13 square equals 7 square plus 8 square plus 2 times 7 times 8 cosine alpha. That means 7 square plus 8 square equals 113. 169 equal 113 plus 112 cosine alpha. That means finally 112 cosine alpha equal 169 minus 113. Cosine alpha will be equal 56 over 112. Finally it will be 1 over 2. Shift cosine 1 over 2 or cosine minus 1 over 2, alpha will be 60 degree.